Okay, here I'm going to introduce how to solve an absolute value equation. To solve an absolute value equation, I'm going to ask you to remember the fundamental goal of solving an equation. It's the whole purpose of what we're trying to do. The goal of solving an equation is to find all the values for the unknown that make the equation true. So let's remind ourselves what this means by looking at an example from Algebra 1. So let's say I have the equation x plus 1 equals 10. So some unknown value plus 1 equals 10. I think we all agree that you could subtract 1 from both sides, or you could just look at this equation and come up with the solution. X must be equal to 9. That's it. That's what it means to solve an equation. And we found the value of the unknown that makes this equation true. If I plug in 9 for x, 9 plus 1, it will equal 10. So that is the goal of solving the equation. So let's see how this relates to an absolute value equation. So say I have an equation, the absolute value of x, close absolute value, equals 3. So in terms of our geometric interpretation, this means some number who has a distance of 3 from 0. So you could draw this number line and say here's 0. If I go to the right 3, 1, 2, 3, I know I have the number 3. So this must be a solution of the equation. But again, we could also go to the left 3. So left 3 would put us at negative 3, and this would also be a solution of this equation. So I've reached the conclusion that the solution set, or the set of solutions, are negative 3 and 3. And this is pretty easy to verify. If I plug in the absolute value of negative 3, it of course equals 3, just as the absolute value of 3 equals 3. So here we found the solutions. The solutions are, there's two potential solutions. There's two solutions, x equals 3 and x equals negative 3. Those are the two solutions to this equation. This works just as well as if we had taken the absolute value of an expression like x minus 2. Say I take the absolute value of x minus 2, close absolute value, and I say that's equal to 4. So here's what I know. Inside these parentheses in this previous equation, absolute value x equals 3, it had to be 3 or negative 3 in here to equal 3. I know whatever is inside these parentheses, it has to equal one of two numbers. Either what's in here has to equal 4, and I take the absolute value of it and it equals 4, or whatever's inside here has to equal negative 4. And when I take the absolute value of it, I will obtain 4. So let's do exactly what I said. What's inside here has to equal 4, so x minus 2 has to equal 4, or x minus 2 equals negative 4. And I can solve both of these equations. Add 2 to both sides, I have x equals 6. Add 2 to both sides, I have x equals negative 2. So here are my solutions to this equation. The open absolute value x minus 2 closed absolute value equals 4. I have x equals 6 or x equals negative 2. And we can verify this. Let's plug in 6 here. I have open absolute value 6 minus 2 close absolute value equals 6 minus 2 is 4. So this is the absolute value of 4, which of course equals 4. So that's true. And if I take the absolute value of negative 2 minus 2, negative 2 minus 2 is negative 4, and the absolute value of that is 4. Okay, so here, this builds us up to the general idea of how we're going to solve these equations. And I think I'm going to leave that for the next video of what we need to do to solve a general absolute value equation, and let you think about it until you watch the next video.